In this video, let's take a look at the concept of imaginary numbers. Before we can understand what imaginary numbers are, we need to know the rationale behind the extension of number systems. The first number system that we have ever learned should be the natural number system. This number system contains all the integers starting from 1. People found that this natural number system is problematic when the concept of subtraction is involved. For example, for 2 minus 5, no answer can be found in this number system. Of course, we can try to say that 2 minus 5 is meaningless or undefined. But if 2 minus 5 is undefined, then 2 minus 5 plus 6 is also undefined. However, 6 minus 5 plus 2 is well defined, and it is equal to 3. Therefore, if we do not allow 2 minus 5 in our arithmetic calculations, then we must treat 2 minus 5 plus 6 and 6 minus 5 plus 2 as totally different expressions. That means every time when we do addition and subtraction, we need to check for many undefined cases. And this adds a lot of complications in arithmetic. Therefore, to make the number system less problematic, people introduced the concept of zero and negative numbers, and the number system was then extended to integers. However, similar problems may arise in this integer system when the concept of division is involved. For example, for 6 divided by 9, the result is undefined under this number system. As a result, the concept of fractions was introduced, and the number system was then extended to rational numbers. Similarly, problems may further arise when the concept of square roots is involved. For example, for square root of 8, the result is undefined under the rational number system. That's why in the last video we have learned the concept of irrational numbers. Rational numbers together with irrational numbers form the real number system, and these numbers have completed the real number line. Then, out of imagination, mathematicians started to think about this question. What if we try to calculate square roots of negative numbers, for example, square root of minus 4? Of course, root minus 4 is undefined in the real number system. That means we cannot find an answer to the value of root minus 4 on the real number line. Still, out of curiosity, mathematicians tried to think of this. What would happen if I further extended the real number system to make root minus 4 well defined? That's how the concept of imaginary numbers was invented. Imaginary numbers are basically square roots of negative numbers. We call them imaginary numbers because this concept was invented out of imagination. At first glance, imaginary numbers seem to have no practical use in mathematics. However, mathematicians later found that the concept of imaginary numbers was actually extremely important and useful in algebra. The usefulness of imaginary numbers is out of scope of this video, and it will be discussed in the university level. Right now, let's try to focus on how we define and manipulate imaginary numbers. We denote the number root minus 1 by I, where I is called the imaginary unit. Then we know that I squared is equal to minus 1. In this way, we define root minus n as root n times I, where n is a positive real number. This definition makes sense because the square of root n times I is equal to minus n, if we are allowed to apply the laws of integral indices. With this notation and definition related to imaginary numbers, we can do arithmetic involving imaginary numbers. For example, for root minus 2, by definition, it is equal to root 2 times I. For root minus 4, similarly, it is equal to root 4 times I, and hence it is equal to 2i. For 2i plus 3i, we can just group the like terms as usual. So it is equal to 5i. For 2i times 3i, again we can just do multiplication as usual. So it is equal to 6i squared, which is then equal to minus 6 because I squared is equal to minus 1. Lastly, for 2i over 3i, we can cancel out common factors as usual. So it is equal to 2 over 3. This is how we can manipulate imaginary numbers.